Good afternoon. I am Shelly Singla from GPC Kundi Majra. Today my topic is Gauss's law and its application. To start with the topic, first of all we will discuss what is Gauss's law. According to Gauss's theorem, the total electrical flux through any closed surface is equal to the amount equal to 1 upon epsilon naught times the charge enclosed by this surface. Now, let us explain this. Suppose we have a charge q which is enclosed in a given surface whose surface area is S and its radius is, let us say it is d. Now, according to Gauss's theorem, the total electrical flux which is phi will be equal to charge enclosed inside the surface divided by epsilon naught, where epsilon naught is the absolute permittivity of free surface. So, this is our Gauss's theorem. Now, we will derive this formula. Its proof is let us suppose we are given a point charge plus q at any point O. Suppose we draw an imaginary surface around this charge. The radius of this sphere is d and its surface area is S. Now, let us take this surface area which is very small. This surface area is ds and its vector is ds vector which is perpendicular to this surface. Now, the electrical field from originating from this point charge q will be in along this same direction which is given by E vector. So, E and ds vector are along the same direction. Now, we know that flux phi is equal to E vector dot S vector. This is the definition of electrical flux. Suppose we have to calculate the small electrical flux through the surface area ds. This small flux is given as d phi. This will be equal to E vector dot d s vector. This is the dot product of electrical field originating from the charge q and ds vector. So, if we have to find the total electrical flux phi originating from the charge q through the total surface S, we will integrate the small electrical flux d phi over the closed surface S. So, we get E vector dot ds vector. We integrate this over the closed surface S. So, now E vector and ds vector are along the same direction. So, the angle between them is 0. We can write it as E vector into ds into cos 0 degree over the surface S. Cos 0 is 1. So, this is equal to E into ds over the closed surface S. Now, the formula for the electrical field due to the charge q at any distance d can be written as charge itself q divided by 4 pi epsilon naught, where epsilon naught is the permittivity of the free surface, into d square. D is the distance at which we have to find the electrical field, and a unit vector d cap. Or we can simply write E as 4 pi epsilon naught d square. Now, putting these values, we have q upon 4 pi epsilon naught into d square into ds over the closed surface S. Now, q 4 pi epsilon naught and d square are constant, and these can be taken outside the integration. So, we have integration of ds over the closed surface S. Now, we have considered this as a Gaussian surface. This Gaussian surface is a sphere. It is a sphere. Its radius is d. So, its surface area S is equal to 4 pi into d square. So, when we integrate ds, we get a total surface area S, which is equal to q upon 4 pi epsilon naught into d square into S. S is equal to 4 pi into d square. Now, 4 pi cancels out with 4 pi and d square with d square. So, we get the expression phi is equal to q upon epsilon naught. So, the formula for flux, electric flux, is equal to q upon epsilon naught according to Gauss's theorem. Hence, we have proved this formula. Now, we will explain the applications of Gauss's law. Applications of Gauss's law. There are various type of applications of Gauss's theorem. First is we can find the deduction of Coulomb's law. From Gauss's theorem. We can deduct Coulomb's law, which states that F force between two charges is equal to q into q naught upon 4 pi epsilon naught into d square, where d is the distance between the charges q and q naught. We can deduct this formula. Second is we can find various type of electric fields from Gauss's law. We can find the electric field of solid sphere, number 2 hollow sphere, third is line charge, and fourth one is sheet of sheet. So these are various applications of Gauss's law. We will explain these applications one by one. First is the deduction of Coulomb's law from Gauss's law. So, to deduct this Coulomb's law, so let us suppose we have a point charge Q located at point O, and another point charge Q naught is situated at a distance d from this charge. Now let us draw a sphere, Gaussian surface, including this point charge Q naught. The radius of this sphere is d and the surface area of this sphere is S. So let us take a small surface area of this total sphere S, whose surface area is ds, and ds vector is along this direction. Here Q naught charge is located, and also the electric field due to this point charge, which is also known as source charge. It is because it is producing the electrical field E at this point. So the direction of electric field is also along the direction of ds vector. So E vector is parallel to ds vector. Now we know that electrical flux phi is equal to E vector dot ds vector and its integration over the closed surface S. So this is equal to integration of over the closed surface and E into ds into cos 0 degree. Because E vector is parallel to ds vector, so the angle between both is 0 degree. Cos 0 is 1, so we have phi is equal to E into ds. Now another formula for phi according to Gauss's theorem is according to Gauss's law, phi is also equal to q upon epsilon naught. So this is equation number 1 and equation number 2. So from 1 and 2 we have integration of E into ds is equal to q upon epsilon naught. Now E is equal to q upon 4 pi epsilon naught into d square. So E into ds, integration over closed surface S, this is q upon epsilon naught E into 4 pi d square is equal to q upon epsilon naught. E is equal to q upon 4 pi epsilon naught into d square. So we have derived the formula of electric field due to point charge q at any distance d. This is the electric field. Now as we know, we have system of two charges. First charge is q and second charge is q naught, and we have to find the Coulomb's force F between these two charges. So we also know that electric field is equal to Coulomb's force between these two point charges divided by the distance d. The distance between these two charges is d. So sorry, q naught. Electric field is equal to force upon this test charge. We have to find the force on this unit test charge, which is called as electric field E. So F is equal to E into q naught. This can be written as q upon 4 pi epsilon naught into d square into q naught. If we have to write it is in vector form, then we take a unit vector d cap. D cap is a unit vector along this direction whose magnitude is unity. So we have deduced the formula for electrostatic force between 2 point charges q and q naught from the Gauss's theorem. So this is the first application of Gauss's theorem. Now the second application is we can find the electric field due to a solid charged sphere. Now the second application is we can find the electric field due to a solid charged sphere. Suppose we have a solid sphere. This is center O. Its radius is d, and we have given it a positive charge. Which is distributed uniformly over the whole sphere. So the total charge given to this sphere is q. Now we have to find different electrical fields at different points. Suppose the first point is P, which is lying outside the sphere. We have to find the electric field at this point. Let us join the center with this point P. At this point P, the electric field will be along the radial direction. and at this point P, let us consider an imaginary surface or sphere which is called a Gaussian sphere of radius r. Let us take this as d and this as r. This as r. Now, first is we will find the electric field outside the sphere. Now, at this point phi is equal to E vector dot ds vector. This is the definition of electrical flux. This can be written as, at this point the electric field is along the direction and this small surface area is ds. Its direction is also along E vector. So, angle between these is 0 degree. We can write dot product with angle cos 0 degree. So, this is equal to E into ds and its integration over the closed surface S. Now, the surface area of this Gaussian sphere is equal to 4 pi into d square, because d is the radius of this Gaussian surface. So, we can write E into 4 pi d square. Phi is equal to E into 4 pi d square. This is also equal to q upon epsilon naught, because charge q is placed at this point. So, the electric field is equal to q upon 4 pi epsilon naught into d square. So, this is the formula for the electrical field outside the solid sphere. In this case, we can take rho as volume charge density. The volume charge density is equal to q upon volume of the sphere V. This is equal to q upon 4 upon 3 pi into r cube. Now, if we let us divide this with 3 and multiply it by 3, and here multiplying it with the r cube and dividing and multiplying with the r cube, we get E is equal to q into r cube rho into r cube upon 3 into epsilon naught into d square. So, this is the formula for electrical field at any point which is lying outside the surface. Now, we will find electrical field at the surface of solid sphere. We have charge q which is lying inside the solid sphere and it is uniformly distributed. Now, the radius of this sphere is r and we have to find the electrical field at the surface. Now we have derived the formula for electrical field outside is equal to rho into r square upon 3 epsilon naught into d square. Now in this case d becomes equal to r. The point which was lying outside, now it is at the surface of the solid sphere. So distance d becomes equal to radius of the sphere. On putting it, we have E is equal to rho into r square upon 3 epsilon naught into r square, this is r cube, and this becomes equal to rho into r upon 3 epsilon naught. So this is the formula for electrical field at the surface of the solid sphere. Now third is we will find the electrical field inside the surface. Suppose we have this point which is lying inside the solid sphere and it is at a distance small r from the charge q lying at the center. Now taking this point, we will draw a Gaussian sphere whose radius is r. So the radius, this surface area S dash of this sphere is 4 pi r square. Now the flux phi is equal to inside the sphere the flux phi is equal to E vector dot ds vector. At this surface we have taken small surface area ds vector. The electric field is E vector lying along this direction and ds vector is also lying along the direction of electrical field. So this is equal to E vector E into ds into cos 0 degree. Cos 0 is 1, so we take it as E into 4 pi r square. The surface area is 4 into pi into r square. Now the flux phi can be taken as q dash upon epsilon naught. Here the charge is taken as q dash because inside the sphere the total charge is q, and if we have taken a Gaussian surface inside this sphere, the charge will be q dash, which will be less than the q. So the electrical field is equal to q dash upon 4 pi epsilon naught into r square. Now since the charge this is a volume charge distribution, the volume charge density rho is equal to q upon 4 upon 3 pi r cube is equal to q dash upon 4 upon 3 pi r cube. So q upon r cube is equal to q dash upon r cube. So on solving it, we will get rho r upon 3 epsilon naught. So the electric field inside the sphere will be equal to rho r upon 3 epsilon naught. So we have find different types of electrical field for the solid sphere. at different points. Now the next application is to find the electrical field due to a charged spherical